We are going to look at domain and range of a function. When we talk about domain of a function, we are basically talking about any value or any number that you can put into that function and you not violate any mathematical rules. So any real number that you can put into the function and the function will still be valid or it will be defined, then that's the domain of a function. So if you see a polynomial for polynomial functions, every real number will make the function defined. What is a polynomial function? A polynomial function is a function where you'll be seeing variables and constants. So the variables here are raised to what? A particular power. And this power belongs to the set of what? Whole numbers. The power of the variable belongs to the set of whole numbers. And we know whole numbers are numbers starting from 0 till infinity. So 0, 1, 2, 3 till infinity. So that is a polynomial. So if you have 2x plus 5, this is a polynomial, just as it's linear. If you have x squared plus 3x plus 5, this is also a polynomial, but it is quadratic. If you have x cubed plus 2x squared minus 3x plus 2. This is also a polynomial, specifically a cubic function, and so on. So all these polynomials, their domain is the set of what? All real numbers. Any number at all you fix into this is going to make this function defined. So rule number one, for polynomial functions, their domain is what? The set of all real numbers. So rule number two, rational functions. So what is a rational function? Rational function is a ratio of two polynomials. So in other words, a rational function is of the form a over b, where b is not equal to 0. Why? Because we do not want to what? Violate any mathematical rules. If you take your calculator and you punch 5 over 0, it will give you math error. Yes, it is undefined. So rational function, a ratio of two polynomials. So this is a polynomial. This is also a polynomial. So this, because it's a ratio of two polynomials, it has become a rational function. And here the domain is not all possible real numbers, because we do not want here to be 0. So you have to find the values that will make this thing 0. And then your domain will be the set of all real numbers except those values that will make what? This denominator 0. Because once this denominator is 0, you are violating mathematical principles, which means that this function will not exist again. It will be undefined. So this is rule number 2. Rule number 3, you will not see polynomial functions or rational functions, but you will see maybe something in a square root. So if there is anything under a square root, you know that you do not have square root of what? Negative numbers. Its square root of negative numbers is undefined. But we can have square root of 0. Square root of 0 is 0. But you must also be careful. So there's a fourth case where maybe 2x plus 3 all over square root of x squared minus 16, something like this. Now when you come here, even though we have um, square root of 0 is defined, but when you come here, this looks like rational. It's of the form a over b. Now if the down here is 0, then this whole function would be what? Undefined. Even though square root of 0 is 0. So, but when it comes to a fraction like this, we must be careful here too. We must exclude what? The 0. The 0 shouldn't be part. Here, we are saying that we do not want negative numbers. So here, everything here should be greater than or equal to 0. But here, the top, we're okay with the top because it's a polynomial. It will be what all real numbers can fit in. But for here, some real numbers will not survive. So here, x squared minus 16 should be greater than 0. We shouldn't include 0 because we do not want here to be what? 0. If everything here becomes 0, root of 0 is 0, and this will be what? Undefined. So that is basically domain. Now, if you look at these two things I've done here, I'm finding the values that will work. you could have gone ahead. So if I find the values that will work here, you could have gone ahead to find the values which will not fit in. You could have found this x squared minus 16 is less than 0. So whatever values you find here, then your domain will be read as what? X, such that x is a member of all real numbers, except when then you fix in these values. But here, you are finding what will work. Just like here, I'm finding what will work. So if I want to find what will not work here, I would have done x squared minus 16 less than or equal to 0. So let's solve some two examples and we are done with domain. So let me take this. We have 3x squared plus 5x minus 3. What will be the domain of this function? It's a polynomial, so x such that x is a member of all real numbers. This is our domain. We are done. X plus 5, same thing, is a polynomial. Root of 4 minus 7t. Over here, we must be careful. So we can find the values which will not satisfy this. We know that 4 minus 7t, if it's less than 0, I mean if everything here is negative, it will not work. So 4 less than 7t, we can say t is greater than 4 over 7. So this is not working. So we are saying x such that x is a member of R except t is greater than 4 on 7. Sorry, it's t, so not x. Yeah, this will be our domain. Instead of writing the except, yeah, so that's it. You could have also found, you could go ahead and find the values which will work for this. So 4 minus 70 should be greater or equal to 0. Then we are also cool with that. So t is less or equal to 4 on 7. So x such that x is a member of all real numbers where t, oh, I'm repeating the x again. And so this is t, sorry, where t is less or equal to 4 on 7. So in objectives, you should be watch out any of this can work. So that's how you find domain. We are good with domain. Okay. Then now let's look at range. How do you find range of a function? So to find range of a function, you have to equate it to y, and then you make x the subject. Then whatever you find the domain of it. So let's say we have 5x plus 5. We are on range now. Want to find the range of this. So y, so f of x equals this. Y equals 5x plus 5. Now make x the subject. Y minus 5 equals 5x. X equals y minus 5 all over 5. After making x the subject, whatever you have, find the domain of this. What will be the domain? The down is just a number, so ignore it. The numerator is what? A polynomial. So y such that y is a member of what? R. So here all real numbers. Because we are only having a polynomial at the top. If we are having 2x plus 7, f of x equals this. We equate it to y, make x the subject. So here x is y minus 7 on 2. The down is just a number we ignore. The top is a polynomial. So y such that y is member of R. So here to all real numbers, this is the range. The range is just defining the domain. So the possible images of the domain, we call it the range. So if I give you something like square root of 4 minus x and ask you to find the range of this, you don't need to go and equate to y or do whatever. Just ask yourself, if you consider all real numbers, which real number can you put into this to generate a possible image? You know that negative numbers cannot work. So any real number you pick, you must make sure that this thing shouldn't be negative. You get it? So the possible images we can have here can start from 0, then going to infinity. So here you can just see everything is obvious over here. This will be our range for this. So that is it on range and domain. let me give you one question under domain, and you can leave your answer in the comment section. All right, let's just solve one question on domain. So we have f of x equals x minus 4 over x squared minus 2x minus 15. It's a rational, right? A rational function. This is a polynomial. This is another polynomial. Ratio of two polynomials, rational. Okay, how do we get the domain now? We don't care about the top. We know it's all real numbers. But the down, if the down is 0, we are in trouble. So let's find the values which will make this undefined. Let's equate this to 0. Whatever values we find, our domain will be the set of all real numbers except those values. So x squared minus 2x minus 15 equals 0. And let's quickly use our calculator to solve this. Mode 53 1 minus 2 minus 15. We have 5 and negative 3 as our answers. So x plus 5, x minus 5 rather, and x plus 3 equals 0. So x equals 5 or negative 3. So what to be our domain? X such that SML of R, but x is not equal to 5, or x is not equal to negative 3. Because once we fix in 5 and negative 3 here, this thing will become 0 and this function will be undefined, or it will cease to exist. This is all on range and domain. Now next video we'll look at absolute value equations and inequalities.